Welcome to AZTechCast, sponsored by Arizona Technology Council, with your hosts, Steve Zylstra and Karen Nowicki. AZTechCast is dedicated to covering innovation and technology in Arizona and beyond. Broadcasted monthly, AZTechCast invites leading experts to have real conversations about what is happening in the tech sector across the state of Arizona. From regional news to innovative startups, companies, and emerging technologies, AZTechCast covers the critical issues and economic trends propelling the state's growing ecosystem.
Welcome to Phoenix Business RadioX. I'm your host, Karen Nowicki, and I'd like to welcome you to AZTechCast, sponsored by the Arizona Technology Council. The AZTechCast is dedicated to covering innovation and technology in Arizona and beyond. Broadcasted monthly, AZTechCast invites tech and business experts to have real conversations about what's happening across the state of Arizona. AZTechCast discusses critical issues, topics, and trends propelling the state's growing tech ecosystem. And with that, let's give a warm welcome to today's featured guest. We have with us Roy Donaldson, Executive Director of Strategic Missile Defense at Raytheon. Welcome, Roy.
Thank you, Karen.
Thrilled to have you. And David, I didn't ask how to pronounce your last name, so I'm going to take a stab at it. David Hahn, am I got that right?
Spot on. Thank you.
Woohoo, good. I usually take care of that ahead of time. David is the Dean of College of Engineering with the University of Arizona. Welcome, sir.
Thank you. It's great to be here.
And Dr. Russell Cummings, Director of the DoD Hypersonic Vehicle Simulation Institute at the U.S. Air Force Academy. Welcome, Russell.
Thanks. Great to be here.
The distinguished leaders join Council President and CEO Steve Zylstra to discuss what hypersonic research is and why it's so important, the major tech and infrastructure challenges in hypersonics research, and the importance of continued collaboration between state universities and tech companies for Arizona. We have a lot of interesting content to cover, so we're going to go ahead and dive in right now. Before we talk specifically about our topic at hand, I always like to ask for a few moments of introduction from each of you, and any one of you can start, but just tell us who you are, where you're zooming in from today, and how you landed to where you are. I know I'm asking for probably a whole career's worth in a couple of sentences, but we've got an hour. Let's go for it. David, Russ, or Roy, who can kick it off for us?
I'll dive in.
Thank you, David.
So I'm the Craig M. Burge, Dean of the College of Engineering here at the University of Arizona. I came to UA in July of 2019. Previously, I'd spent more than 20 years at the University of Florida. One of my jobs at the University of Florida was to manage our research and education partnership with the U.S. Air Force at Eglin Air Force Base. So when I looked at this opportunity, one of the many appeals to joining U of A and moving across the country was to create a vibrant Department of Defense engagement and funding portfolio, both research and education, to engage with companies like Raytheon, the Air Force here, Davis-Monthan's Office of Naval Research, and really build out that research and education portfolio in support of the United States and the Department of Defense. So hypersonics is one of our strategic priorities. And, we've really put U of A out front as one of the leaders. So it's exciting to be here, to have the collaborators around us and the partnership. So that's why I'm here, and it's great to be here.
Thank you, David. Russ, you're ready. You look ready.
Okay, I'm ready. I'm Russ Cummings. I am here in Colorado Springs, Colorado, the home of the Air Force Academy. I started on my career at Hughes Aircraft Company Missile Systems Group, which is now Raytheon in Tucson. So there's a connection there from the very beginning of my career. I then went into academia. I was a professor at Cal Poly and a department head in San Luis Obispo, California for about 18 years. And now I'm a professor at the Air Force Academy and also the director of the DoD HPCMP Hypersonic Vehicle Simulation Institute. I also spent 3 years as the tech director of the AFOSR office in London, where we oversaw research that the Air Force was sponsoring throughout Europe. And I also was responsible for hypersonic research around the world. So a lot of background in hypersonics.
Excellent. Roy.
Good afternoon. I'm Roy Donaldson again. and I'm with Raytheon Missiles Defense here in Tucson, Arizona. I've been with the company for about 22 years, and it's flown by. I mean, I think of my career so far, and I'm a product area director in strategic missile defense, and so I have the pleasure of working with an awesome team that builds and delivers strategic sea-based systems that help defend our nation and our allies' missile defense. And so it's definitely a humbling responsibility, and it's very interesting. It's a very dynamic field in the area of missile defense. And so my past is I'm a graduate of West Point, the U.S. Military Academy, and served 5 years as a military intelligence officer right here in Fort Huachuca, Arizona. I spent time and served here. And then my wife is a graduate of the University of Arizona and is working in economic development in Southern Arizona. So she works with regional communities and groups in terms of economic development. And there's a lot of demand for economic development right now, given the pandemic. And before I came to Raytheon, I worked as a systems architect at Booz Allen and Hamilton. And so that's a little bit about my background, but I'm on the Dean's Advisory Board at the University of Arizona Engineering College. I'm also an industry advisory board member for the National University Consortium on Applied Hypersonics. And I'm very proud to be a member of the Davis-Monthan 50 that supports Davis-Monthan Air Force Base here in Southern Arizona. So those are some of my passions and things that I'm doing. And then, as Russ alluded to, we've been here about 70 years here in Tucson, Arizona, Hughes, and now Raytheon Defense. And we've got about 31,000 employees. The headquarters of that business unit is right here in Tucson, and we're in 28 countries with over $15 billion in annual revenue. So we're really bringing the most advanced end-to-end solutions for our customers that detect, track, and defeat threats. And so, we're looking to solve some of the hardest problems out there for our customers. And I like this because hypersonics is a really hard problem.
You could not have kicked off our conversation any better. Thank you for that, all of you. And Steve, we have another incredible panel. I'm always just blown away with the folks that we bring on board. If you take a moment, for those of our listeners who don't know who the AZ Tech Council is or who Steve Zylstra is, if you would introduce yourself, and then, let's tee it off with where Roy just left off for us. Why this group?
Thank you, Karen. It's always a pleasure to be here and to interact with such great leaders in our state in the tech industry. The Arizona Technology Council is a statewide organization with offices in both Phoenix and Tucson. We have about 750 member companies across the state. We do public policy advocacy on behalf of the tech industry at the state and federal level, put on about 150 events a year. We have a number of major publications. We do 2 podcasts, and we negotiate lower cost products and services for our members, like our association health plan and our 401k program. I'd like to also mention about myself. I'm a recovering engineer. I spent 20 years in the aerospace and defense industry. And I've been now running tech councils for 20 years. So it was a while ago. And Roy will appreciate this. I worked at Ford Aerospace, and I was the responsible mechanical design engineer on the guidance and control section for the Sidewinder AM9L and AM9M. So also worked for Bendix Guidance Systems Division. We made attitude control systems for spacecraft and a couple of smaller technology companies here in Arizona. So it's really good to have this group with us today, and looking forward to getting started with the questions.
Steve, I just have to add, once an engineer, always an engineer. So
one of the things I didn't mention is I've been on the U of A Dean's Advisory Board for about 30 years.
Wow.
So through 4 deans for sure, maybe 5.
I'm really grateful to have you continue too. I always enjoy your input.
Excellent. So listen, let's start with the basics for those of us that need basics. What is the hypersonics, and why is research in this area so important? And I would really love for this just to be well-rounded. We don't have to necessarily take turns. jump in there and add a comment to somebody else's. Sometimes with Zoom, we interrupt each other more than if we were in person, but we're all Zoom experts, as Roy, I think it was Roy that pointed out somebody before we went live. What is hypersonics and why is research in this area so critical?
Well, I thought maybe I would just define it first, since I'm a professor and so I teach.
Good at defining things. That's
right. And I ask my students all the time, why do we need an area, a flight regime called hypersonics when we have one called supersonics? And that's because when the speed of a vehicle starts to get higher and higher and higher, usually people say around Mach 5 and higher than that, certain things start to change and get more difficult on the vehicle. And that largely is associated with the high heating that takes place behind the shock waves. So the heating not only affects the vehicle directly, the materials interacting with the heat, but it also affects the air that's flowing around the vehicle, because the temperatures have become so high that the air starts to change into other chemical constituents through high temperature chemical reactions. So a great many things start to happen, all of them not good, very challenging, very difficult to designing the vehicle. And that's why hypersonics exists as its own speed regime.
Can I just ask a follow-up to that? Why is it important for us to get to those speeds? What is the ultimate outcome that either the military or commercial companies like Raytheon are looking to achieve?
So one of the things that has always been true in the aerospace industry is the quest to go faster and faster and faster. For about the last 50 or 60 years, we haven't continued to do that as much as we did for the 50 or 60 years before that. So there's always just that as a goal. But for example, our commercial aircraft that we fly on every day, or more and more now, haven't increased in speed at all for decades. But what happens if you put hypersonics into the military area is you start to critically decrease the time someone has to respond to a threat. So if an airplane's flying at you at Mach 2 and has a Mach 3 or 4 missile on it, there is a time that you can respond. If that's all happening at hypersonic speeds, that time is greatly reduced. There's even questions about, well, can you respond in time as a human being to that situation?
And I will just add, Russ, if you look at some of the countries in this world that are near peer competitors, they are investing heavily in hypersonics infrastructure and technology, because the speed of these vehicles really give a significant strategic or tactical advantage, as you indicate. But it's just not speed, but these systems have unpredictable maneuvering and high-end maneuvering. So it's very difficult to detect, track, and engage those threats. And so the DoD in their FY22 budget put $6 billion in this next fiscal year in hypersonics. So DoD, the Department of Defense, is looking at it as one of their top modernization priorities. We're seeing in the news with China and Russia, there's tests that are coming out, complexity of systems at all ranges, but speed and maneuverability of these systems is a great concern.
You mentioned the word infrastructure. So what are some of the challenges in both technology and infrastructure when it comes to the hypersonic research that's now going on?
I'll give a start and then turn it over to my colleagues. From the university perspective, as Roy and Russ just mentioned, huge technical challenges of studying the aerodynamics and the materials. Can materials withstand those great frictional loads of moving through the air at 5 times the speed of sound or 6 times the speed of sound? So we need to build facilities to emulate and test those. And we kind of break those into wind tunnels, where I think we all kind of understand the concept of the wind tunnel, where you see the model and the air flowing over it. But as we make that air move faster and faster, the challenges of doing that become greater and greater and greater. So for universities to build out the wind tunnels to test these devices and the high energy furnaces to synthesize ceramic materials to test in these wind tunnels, it starts to be a challenge to our infrastructure. We're talking investments that can be in excess of 10 or $20 million or more. And that's often larger than a university can accommodate. So that's where the partnerships and relationships become so important, where the university can partner with companies like Raytheon and others, and to our states like the state of Arizona, to sort of build that three-way partnership where we can put up some of the seed investment to build these facilities, and then we can bring in the research contracts from both the government and from industry to then make them sustainable. So it's quite a challenge, and it absolutely takes a partnership to solve those challenges.
But just as an example of the wind tunnels that the Dean just mentioned, when we were doing a lot of hypersonic research in the 1950s and the 1960s, there were about 78 hypersonic wind tunnels in the United States. Today, there's less than 50. Most of those, about half of those, were at universities, and many of those went away. Some of those were in the aerospace industry, and almost all of those went away. And now we're in the state of trying to catch back up and rebuild some of those capabilities. But it takes 5 to 10 years from the first drawing of your wind tunnel and ideas for it to when it's actually ready to go and online. And as the Dean said, and that's very expensive. So wind tunnels are a big part of the issue. But the place where that can happen the quickest is at universities. Yet the challenges the Dean mentioned are there. Most hypersonic wind tunnels are very long, easily 30, 40, 50, 60 meters long. So the length of football fields almost, and the footprints are large. And that doesn't usually go in a building in the center of campus.
Well, you mentioned or alluded to support from the state. In the most recent budget that came out of the legislature, there was funding for the hypersonic wind tunnel and research. And it's always important that the taxpayers, both at the state and federal level, understand, what they're getting out of it. And you alluded to some of this earlier, but can you speak further to the benefits that we get both as a state and as a nation?
Yeah, absolutely. This past legislative session, the spring of 2021, the University of Arizona was very deliberate in working with our legislative leaders through the Board of Regents, through what they call the New Economy Initiative, which I believe you're familiar with, Stephen. Yes. That New Economy Initiative is really an investment in Arizona to provide the workforce and the high-tech jobs to really drive the Arizona economy. These are STEM jobs, these are engineering jobs, these are highly trained technician jobs. And so it was a wonderful, from my perspective, a wonderful sort of coalition where companies like Raytheon and other defense contractors in the state spoke with the legislative leaders and said, we need this investment there. As Roy said, $6 billion of research funding out there. We need to bring that to the state of Arizona, and we need some infrastructure to do that. The university leadership, President Robbins, myself, went and explained to them that, there's return on investment in this. This isn't just, hat in hand. This is a very strategic initiative that will actually provide those hundreds of millions of dollars of research, billions of dollars flowing in to the state of Arizona, which pays the wages to not just the primes like Raytheon, but to the whole supply chain and hundreds of smaller companies. So everyone kind of came together to see that full cycle, Steve, and it was pretty exciting because at the end of the day, it was a very popularly supported initiative that kind of passed readily. And we're really excited to use that infrastructure investment to build out some of these Mach 5 tunnels, push them to Mach 6, Russ, and be able to, provide a research infrastructure for directly our faculty and students, but also companies like Raytheon can come and test with us. So it's been pretty exciting. I'd like Roy to give his perspective. Sorry to take over, but he was a partner in all of this. So I'd love Roy to have an opportunity to give his side from the industry perspective.
Well, we see this as a win-win for both. I guess maybe three wins, because win for the state, win for University of Arizona, and win for industry. Because for us to send some of our models and engineers hundreds of miles away to go do testing, and maybe that wind tunnel would not be available because it's all booked up, because there's only a few wind tunnels, as Russ indicated. And so having a resource locally allows us to do testing on some of our top programs. And then it gives our aerodynamicists hands-on testing, they get to understand the system and then accelerate our development based on those results. On top of that, it's a great test bed for students that we get to meet. We can do research. And so we're going to pay Arizona. Hopefully they'll give us some slots to be able to use, but we're going to pay by the hour. And so it's a revenue generating thing for the university. And on top of it, it's just great to partner with a university that has students that are interested in those programs. And so we see it as a STEM workforce development tool. We see it as a place to test some of our top models for our programs. And finally, for DoD to accelerate this development, because we're in competition. We're in competition with other countries that are building, these systems. And in addition, we're in competition with other states. Other states are doing a lot to try to attract hypersonics engineers, and this is one way to do it.
Absolutely.
Let me just give one quick example of all that. I mean, as the director of the Institute at the Academy, I don't just have people at the Academy doing research. I fund projects around the country and in some cases around the world. One of my projects is with the University of Arizona because of the well-known expertise of the faculty members there for the specific issues that I'm trying to deal with. That project is going on, and engineers from Raytheon are going to the weekly, or attending via Zoom, the weekly research meetings, because they want to be interacting with the faculty and the students as they go through the process of developing the models that someday will be at Raytheon. And that's the whole thing in a nutshell, but a small nutshell, but that's an example.
This is a fantastic one, right? We have the military academy, we have the industry Raytheon, we have the state land grant university, all working together seamlessly. It is pretty exciting.
Yeah,
you talked about the new economy initiative. Tech Council lobbied very hard on behalf of that as well this last session. And I was both amazed and pleased to see that the universities in an unprecedented fashion actually got more money than they asked for, which has never, ever happened before. So I think it has a lot to do with the extraordinary way in which this brings value to the state. We talked a little bit about the national and state benefits, but how do, there's a lot of, I remember the superconducting super collider, right? These are big, massive programs that are going to lead to new capability. How do we ensure that these kinds of long-range, relatively high-cost projects actually come to fruition?
Yeah, I think we all probably have some insight, but I'll give you one small answer. The DoD is investing over $100 million now, and it will grow in the University Consortium on Applied Hypersonics, UCA. And the applied is the key word, because the focus of that program is to take the talent pool in the universities at Russ's school and this school, feed them resources to advance the problems that Roy is trying to solve. So there's a deliberate focus with that program and others to not do basic research like at a superconductor and answering, general physics problems, but really coming down and applying to solve applied problems. How do I make this, seeker work in with the hypersonic flow over it and such? So we're actually taking our engineering abilities to solve problems and transition that right out into industry. So that's a very different focus than some of the more applied, more fundamental National Science Foundation that often funds those big science problems, which obviously we need as well too. Don't get me wrong, but this deliberateness to be applied research is a key way to answer just what you said, Steve.
Any other comments on that?
So I'll just add. Go ahead, Russ. Russ, go ahead.
When I was at the AFOSR office in London, the commander of AFRL visited and asked me point blank. He first stated and then asked me, said, one of the things that keeps me up at night is all of the things we need to accomplish in hypersonics, and we don't have the people, we don't have the facilities, we don't have the faculty to do it. Do you think we can do it? And that was a tough one. I ended up writing a little report and sending it to him about that. But the key, in my opinion, was these partnerships to do applied research. And that's the most important aspect of this. There, of course, is some basic research that has to go on for hypersonics, but most of it is going to be very applied. Faculty aren't always good at that. That's not what their background is. So they're going to have to learn how to do that better. The students are going to have to learn how to do that. And then the government and industry are going to have to realize that those things take time, that you don't just throw some money at a professor and 6 months later you have all the answers. That's just not true. And that's where organizations like UCA, which the DoD is funding, are going to be so important. Bringing together partnerships of universities, industry, and government to work together to solve these applied problems.
And for our listeners, UCA is the University Consortium
On applied hypersonics, that's correct.
Okay.
Yes.
And AFRL is the Air Force Research Laboratory.
Correct.
Yes.
Sorry for the acronyms.
Yeah, I guess you can't have a discussion with some DoD speakers without a bunch of acronyms, right? Unfortunately. So I'll just add, Russ, I agree with Russ and David. The applied focus, I think, is a key element. But there's two other elements. One, it's a national security urgency. I mean, we're seeing it on the news. I mean, when my little son is asking me, why are the Russians going this fast? It worries him. So it is a national security imperative when you see things in the news of similar systems or hypersonic systems. But secondly is what's changed is we're seeing great advances in high performance computing, and that's enabling us to do digital modeling like we've never done before. Instead of doing hundreds of runs of a missile in simulation, we're doing tens of thousands runs very quickly overnight. And so we're actually accelerating our design processes by using, modeling in sim, and then thinking about how we design in a new way. We're talking a lot about digital engineering, having all our suite of tools connected and having the ground truth in a central repository so that there's more accurate engineering predictions. So I think that we're going to go faster across this valley of death by failing faster, learning better, and then also the third part is focusing on developing our engineers quickly, because I've been a missile engineer for 20 years, and it shouldn't take 20 plus years to train up an engineer. We've got to train our engineers in several years to be hypersonics, at least knowledgeable in hypersonics, and it can be done, and just a matter of national focus and priority.
I'm going to cut in here if I could and have us break for a word from our sponsor, because without our incredible sponsors, both the Arizona Commerce Authority and Jdh Insights, these conversations, radio show, and podcast would not be possible. When we come back from this word from our sponsor, I'd like to continue this conversation, and let's share with our listening audience how academia, industry, and government can motivate more students, employees, and allies to get involved in hypersonics research. It seems like a great place to segue. With that being said, I'd like to thank Arizona Commerce Authority, the AZTechCast 2021 innovation sponsor. The Arizona Commerce Authority is the state's leading economic development organization with a streamlined mission to grow and strengthen Arizona's economy. And with that, let's hear a word from Arizona Commerce Authority.
Our streamlined pro-business approach helps you achieve more by putting less between you and future success. Less red tape, lower taxes, less distance separating you from the tech leaders of tomorrow. This innovative ecosystem will supply your business with tools and resources to compete in the 21st century and beyond. But your future is more than just business success. In Arizona, the lifestyle you want is at your fingertips. Explore cities known for their Southwest heritage and modern vision. Enjoy beautiful scenery and endless outdoor activities on land, water, or snow. And if you're looking for a little friendly competition, we've got plenty of teams to choose from. With constant sunshine, vibrant culture, and natural wonder, Arizona provides a style of living that's entirely unique. People from all over the world call our state home. From student leaders who fill the classrooms of our top-ranked universities, to a skilled and abundant workforce that's ready for what's next, to the neighbors, friends, and peers we interact with daily, Arizonans are united by a pioneering spirit that moves us forward. So as you look to the future, know that it's filled with the perfect balance of innovation and high-quality living that makes life better here.
All right. Thank you for that pause. Let's pick up where we left off with the question around how can we continue to motivate more students, employees, and allies to get involved in hypersonics research?
I'll grab this, and then I think Russ is probably going to have some things to say about it too, given his deep experience in academia. In my own mind experiences, I see that students want to go into engineering. They're motivated by many things, but I see two broad motivations. First, they often want to solve what I call big societal problems. And I constantly talk about 4 big societal problems: food and water, healthcare, energy, and security. And security, we check that latter box when we talk about hypersonics. It's a big issue, as Roy has really and Russ have both nicely explained. It's a big national security problem, and that's a motivator. The second thing they do is they often attracted engineering because it's exciting, and they want to work on exciting problems. And I tell you, there's not much more excitement than a Mach 5 or 6, aero vehicle that's heating up to thousands of degrees and its own surface is evaporating away to keep it cool, and it's wild. And so for students to come in and get involved in something like that is a real motivator. So taking on those big societal problems and working on really exciting things is a huge motivator to pull students into the STEM pipeline. And then it's resources, right? We need the resources to, grow our STEM colleges, to bring those students in. We need the funding to fund the research. And it goes back to our conversations around the new economy and its partnerships with industry, with government, with state government to provide the resources, say this is the future of our state, is a high-tech workforce. We're going to invest in that. We're going to put problems out there that are exciting. And suddenly you've got I attempted to say kids. You have our students, flowing into that pipeline. And I'm always amazed at our young engineers, how excited they are and how enthusiastic they are. And that's a great thing.
Yeah, that's exactly the case. I think I can add a few things, but not many, because I think you hit the nail on the head. When I looked at the students that I've taught over the years, one constant for all of them was they wanted to design something. They wanted to do something. And one of their frustrations as they were going through their coursework was they felt like they were always getting ready to do that, but they never got to the point where they did that. And I think hypersonics easily gives you the opportunity to do that with students. because hypersonics is hard. I always tell my students in my hypersonics class is if something's happening on your vehicle that's flying hypersonically and you're not sure if it's a good thing or a bad thing, it's a bad thing. Don't worry about it. But that translates into challenges, and challenges translate into interesting problems to solve. So that's where hypersonics can really attract students. I mean, look at the students who are flocking to places like SpaceX and Blue Origin and Virgin Galactic. They want that kind of challenge out there, and hypersonics offers it. And so I think we need to explain to them and let them know that there are many, many problems to solve in hypersonics, and they're very interesting, they're very difficult, but they're very exciting as well.
I think Russ and David have said a lot here, but I think they're right, is that it's the complexity that draws engineers. I mean, I still remember when, as a small child, I was looking at a submarine, a nuclear submarine, and seeing the intricacy inside that nuclear submarine. That's what attracted me to engineering. And so, we do a lot of STEM programs in the state, throughout the state, to draw people into STEM careers. But I think it's the start of internships. We have a lot of internships, and we put our interns on some of our most advanced technologies so that they get interested. And the intent is an intern over 3 or 4 years will get the training and knowledge so that when they graduate, they've already been with the company for 4 years. They're already a veteran, and they can hit the ground running and further what they've already done before. And so I'm really excited about hypersonics being an area that has a lot of complexity, a lot of challenges. But when we talk about hypersonics, we think of offensive systems and then defensive systems. And in the defensive systems to defeat the threat, we're looking at command and control, computing systems. We're looking at sensors, whether they're on land, sea, air, or overhead sensors, space sensors. And we're also looking at interceptors. We're looking at directed energy. We're looking at other electronics. And so you can see that the field of hypersonics has so many adjacencies in addition to commercial aerospace. I mean, there's people that want to be able to travel. While the airlines haven't enabled people to go faster, that's going to come too. And then commercial space is driving the need for greater and greater propulsion systems. So, we've talked a lot about national security, but there are so many other applications out there. So I think it's a field, and I love that little soundbite and that commercial that you guys gave, because I want people to think of Arizona as the place to learn hypersonics, and that they can go to any of our universities. I mean, we get engineers from ASU, from NAU, or U of A, and because the demand for smaller and smaller electronics, we can. That's an adjacency for hypersonics as well.
Don't forget Embry-Riddle.
Yes. Okay. Yeah, that's a good point. Yeah. So we hire a number of people from Embry-Riddle. Fine program.
My son graduated from Embry-Riddle in aerospace and aeronautical engineering. He's in the Air Force now.
Congratulations, and thank you for his service.
Absolutely. And by the way, you mentioned STEM. I should go this way. The SciTech Institute is focused exclusively on STEM. We have a whole team of staff that do a wonderful job at the SciTech festival that we have every year. It's just finished its 10th year. We run a program called the Chief Science Officers, and it's all about producing future STEM leaders. And it's critical to be the funnel into the universities and into careers in aerospace and defense.
Russ and I are both fortunate in our careers to be in engineering and STEM at a time when it's such an importance to the country and the economy. So, I'm sure I have my other dean colleagues in other colleges that aren't getting the attention that we're getting. And they're hugely important. Don't get me wrong. We have a lot of general education, and we train a well-rounded student. But there's a huge focus on putting students into the STEM pipeline deliberately because we need them in so much of the industries and the problems we need to solve, right? And so it's great to be in STEM, and we're really happy to have these opportunities like contributing to national defense around hypersonics and energy and all those other things.
I think all three of you have mentioned the importance of partnerships. When it comes to the partnership between Raytheon and the University of Arizona, how did that come about? How did that get started?
David, do you want to go ahead and start?
I'll give it a start. So it's interesting. You said 75 years, right? Roy at Raytheon has been in Tucson?
It's 70, 71, 72.
So for 70 years, we've been sending engineers to Raytheon, and not just engineers, UA graduates, but I'm going to focus on College of Engineering. So we have literally 1,000 relationships between this university and that company, Raytheon Missiles and Defense, and all kinds of one-off relationships, collaborations. They do research together. They do workforce, community involvement. And it's been very good, but it's been a little bit ad hoc, and it's just kind of formed over time. So go back a couple of years ago, our president, Bobby Robbins, and their president, Wes Kramer, got together and said, we need to be more deliberate and more strategic in our relationship. And so they met a couple of times. And at the last time they met, we kind of said, we should have some point person. So Wes appointed Roy as sort of his point of contact, and President Robbins appointed me. So Roy and I meet almost every other week and just constantly communicate on research opportunities. He mentioned all the support of the STEM education across the campus. So we thought roll all that up into a very strategic package that Roy and Raytheon invested, actually increased their funding to us. And it's just been a whole higher level, I think, of strategy. Roy is on the UCAS board. One of our faculty members is on UCAS board. So suddenly we've elevated it to a higher level and a more strategic partnership where we're discussing things. We're looking for those opportunities to respond. From my perspective, it's been fantastic, and I've really enjoyed working with Roy. And then I'll just take this a little further. When we went to the New Economy Initiative, I think that relationship and that strategy played out in a way that I don't think many could imagine. I mean, again, Raytheon was telling the story that we're telling. And, I actually had lunch with one of the leaders yesterday, and he was so impressed with, that they're making this investment, but that we're working together. And he was very complimentary that, this strategy and this partnership is something they don't always see. And it was, from their perspective, a real joy and a very sound investment to fund it. So that's a long answer to Steve and Karen, a real important question. I'll let Roy build on that.
Thanks, David. And I really do enjoy the partnership. U of A and Raytheon are the two largest employers in Southern Arizona. So it's definitely a symbiotic relationship. The last few years, we've hired over 2,500 new employees in this area. We're hiring hundreds of more employees just this year. Hopefully we get them locally as well. And so we're constantly in the need for talent as we continue to grow in this state. Last year, we increased our spend level last year with Arizona suppliers to $342 million. So we're spending 8% higher in Arizona in terms of our spend rate. So we've got over 500 suppliers that we engage with and a lot of mentor-protege relationships. So for us, it just makes sense to partner with universities like U of A. We're doing partnerships with the other Arizona universities as well. And so this is really started, as David said, many decades ago. But about 7 or 8 years ago, there was a big focus on hypersonics. In the last 3 or 4, it's accelerated because there's been a lot of discussion. And so hypersonics is a lightning rod for our relationships. And it actually has kind of sped up our relationship in some ways. And so I really enjoy the relationship. But the relationship is also about how we together can mutually benefit each other. And so, and it's not exclusive. We're connecting with other universities. We're partnering with multiple universities, and so we just think it's part of being a good steward in the community, but it's also about talent, and it's also about our future. And so I can't say enough about the relationship. I mean, Russ has kind of talked about how good the relationship is as well. But we're in multiple colleges. We're in the science college. We're in the education college.
Right.
I mean, and so these kind of relationships are pretty broad. It's multifaceted. And the other interesting thing about it is that we don't just hire engineers. It takes a lot of business folks. It takes people that are in a lot of variety of fields. And so David and I talk a little bit about the New Economy Initiative as a platform to help everyone in the state, because there's so many new jobs, support jobs to engineers. I mean, I think in terms of the military, that one infantry soldier may need 8 or 9 support people, and it's similar in engineering.
And I'll just bring Russ into this directly too, and give a shout out to one of my colleagues. One of our newest deans is Dean Gary Packard of the College of Applied Science and Technology down in Sierra Vista. He retired out of the Air Force Academy as a 1-star, and he is very much determined. And Gary and I work very closely being applied science and engineering colleges, and he's determined to strengthen the relationships with some of your colleagues, Russ. You probably know Gary. So, it all comes together in a very positive way.
And in many ways, while the military, the Air Force, in your case, Russ, is often a customer, it's really a partnership as well. Can you speak to how that partnership has developed both with the U of A and with Raytheon around this particular topical area?
Sure. If you talk to people who have worked at universities in hypersonics for a long time, they will say that the community is very small. And that's part of the problem right now. Part of the reason for that is that hypersonics funding for the last 50 years has been very cyclical, and not a nice, smooth sine wave, but a sawtooth. Things ramp up and then they're just canceled. And when you do that, the people, the facilities, the relationships, the collaborations all go away. And you have to completely start over when the next big program comes. And it turns out that the period between those cycles is about 15 years. So you're starting from scratch. And so we have to make sure we're not doing that anymore, that we have people who are working together, collaborating on the government side, in academia, in industry, even with our allies. Having been at the AFOSR International Office, I know that there are incredible capabilities for hypersonics in Australia and the UK. And UCA's trying to encourage the faculty and the researchers in the US to embrace that and bring them into these projects that we're working on. So we have to have that infrastructure that allows us to work together, see other good ideas. I mean, the universities in Australia have done an unbelievable job in developing hypersonics with almost no money, relatively speaking. There's some lessons we can learn there. But yet they were able to fly, a university was able to fly a scramjet in Australia long before anybody else. How did they do that? I want to know those people. I want to work with those people. I want, like we're doing at the academy right now, I want students from their academy to come over to the United States and vice versa, and faculty to find out what they're doing and how they're doing it, because they can teach us some things.
Sure.
So I think it's important that we really start to see each other as collaborators and not competitors or other things as we go through and develop these hypersonic programs.
Karen, I think you wanted to take a break.
Yeah. Well, just because we have a sponsor, not because I need to go file Yes, let's give a shout out to our other sponsor, Jdh Insights. Again, these podcasts and radio shows would not be possible without these folks. A leader in coaching and executive development, Jdh Insights is committed to helping organizations cultivate and leverage their most important and complex asset, their humans. And we've just been talking about that. So with that, let's hear a word from Jdh Insights.
Thank you, Jdh Insights, for being our 2021 Tech Advocate sponsor. A leader in coaching and executive development, Jdh Insights is committed to helping organizations cultivate and leverage their most important and complex asset, their humans. Visit jdhinsights.com to enhance leadership and improve team dynamics to take your business to the next level.
We have only got about 9 minutes left, if you can believe it. The hour goes very quickly. And I can't help but think that every time, Steve, we have these conversations, that the idea of collaboration, Russ just spoke to it, inviting people in and just the cross-training and the information. Roy alluded to it as well, with all the different industries that play a part in the success of hypersonics. It's never lost on this group and everybody that is affiliated with the Arizona Tech Council, that collaboration and communication and that shared mission and vision is critical. With that in mind, Steve, before we go to our last couple of questions, can you give a shout out to our listeners and help them understand, if they're not already, how they can get involved with the Arizona Tech Council?
Yes, thank you for that. Well, first of all, you can go to our website at AZTechCouncil.org. Through this program, you'll be able to get my website, not just my website, but my email, which is szylstra@aztechcouncil.org. There's ways to become a member of the Tech Council, to get involved with our committees, to be speakers at our events, to take advantage of all the benefits that the Tech Council provides. And it's really a way to become part of the tech fabric, the tech ecosystem here in Arizona. We can help you find volunteer opportunities through our foundation to mentor students that are the future workforce for Raytheon and companies like it. And so get involved. We'd love to have you get engaged, and just get in contact with us through that email or through our website.
Great. So I would like to ask around your predictions, and maybe Steve has a question that he wants to put out there before that. But before we close, I want to make sure we talk about what does the future hold for hypersonics research, particularly in Arizona. But, we'll talk about it. Of course, we'll include Colorado and the greater world. What are our thoughts about that? And prior to that, Steve, is there any other question that you want to insert prior to closing with that?
A simple one for this group. So are the challenges that you're facing in hypersonics just a terrestrial issue? We talked earlier about this really friction between these spacecraft that is generated by the atmosphere. Tell us whether we're talking just things within the atmosphere or outside in outer space as well.
Russ, why don't you take a shot at that?
Sure.
I'll chime in if I need to, but I think you've got this one.
Yeah. Theodore von Karman was asked that question many years ago, and his answer was, and he loved to make things simple for people, 100 kilometers. If you're below 100 kilometers altitude, it's an issue. If you're above it, it's probably not. But 100 kilometers includes a lot of the atmosphere and parts of the atmosphere that we're not used to operating in. When Apollo capsules re-entered, of course, they had to come through that part of the atmosphere, but for only 10 or 15 seconds. Now we're talking about vehicles operating at those altitudes where they've never operated in this sustained fashion before. We don't understand, for example, talk about the engineering aspects, the science and the physics of our atmosphere at those altitudes. What kind of particulates are up there? What kind of water vapor percentage is up there? We don't know. We haven't studied those things. So that's where it's a problem. but there's still things about that we just don't know.
Very good. Thank you. Well, let's go on to Karen's question then. And, what does the future hold here in Arizona for hypersonics?
Well, I'll just jump in. I'm hoping by the middle of the decade, we'll be manufacturing at large scale some of these systems, both offensive and defensive counter hypersonic systems. And so, last year, I know one of your sponsors was the Arizona Commerce Authority. We were large manufacturer of the year. And so there's a lot of opportunities in manufacturing, understanding how to manufacture these materials and do these type of systems. There's a lot of science involved in that equally. So as the technology moves on, I'm hoping we'll do a lot more flight testing of these systems, and so you'll hear about these in the news when possible. I think we're going to get to the point where these systems will be starting to be delivered to our warfighter, and they'll have the confidence that both on the offensive and defensive side will be able to handle the threat. And so that's my hope. I'm in a world where it's strategic missile defense. We're always trying to stay ahead of the threat or outpace the threat. But these systems that are going, I've got the Standard Missile 3 system that takes out in exo-atmospheric space systems, threat systems. And so definitely is a humble, big responsibility for our nation, but similarly, we need to get there in terms of delivering systems, to our warfighters with our allies, both offensive and defensive systems. Russ?
Absolutely. I just found out this week that NASA just completed a study for commercial high-speed aviation. They're really looking at the future of commercial transports flying at up to hypersonic speeds. And so there's a whole different set of issues and challenges about that. And so while absolutely our defense of our nation is critical, there's going to be other parts of this that will come out as we look at the capabilities and to develop the abilities to fly at these speeds. And one of them could be commercial aviation in the future.
And I agree with both Roy and Russ. Roy motivated early in this conversation today about our near-peer adversaries, China and Russia. They are investing heavily in hypersonics, and we have no choice. This isn't going to be a flavor of the month or the year where we will cycle out of hypersonics. Now, Russ has been around a long time, and it's been up and down, but this is we often haven't had a peer that was pushing the limits in parallel to us, or perhaps even in front of us in certain areas. So we have to keep doing that. When one looks at, think of an asset like an aircraft carrier with 5,000 people on it. The fact that a Mach 8 missile could overcome its defenses because it's not fast enough to respond is a very scary thing, and we have to be prepared for that. So the future is bright. And then I think what's also exciting, which we haven't really touched on, is these technologies will spin into other industries. So as we develop materials that can withstand these high temperature environments, suddenly we're improving the efficiency of our gas turbines generating power and, reducing greenhouse gases. So there's a lot of positive tech transfer that will come out of the hypersonics programs. It always does. And so that's exciting too. And that's motivating to students.
Steve, what do you think?
Fabulous discussion. Exciting opportunity for the future of Arizona and America. This is a strategic asset, this new capability here in Arizona that will not only impact citizens of our state, but all the other states as well, and with collaborations, other countries as well. So it's an exciting program, and it was great to hear the details about it today.
Thank you so much again for joining us. You've been listening to AZTechCast, brought to you by Phoenix Business Radio with Business RadioX. Today's Arizona TechCast has been brought to you by the Arizona Commerce Authority, the state's leading economic development organization with a streamlined mission to grow and strengthen Arizona's economy. So again, we thank you, Arizona Commerce Authority. And thank you as well to Jdh Insights, the 2021 Tech Advocate sponsor. Visit jdhinsights.com to enhance leadership, and improve team dynamics to take your business to the next level. If you're listening and you're interested in becoming a podcast participant or a sponsor for the Council's AZTechCast, please contact marketing at aztechcouncil.org to lock in your opportunity to further position you as a tech expert, influencer, and innovator. Until next time, I'm Kira Nowicki. Thank you for joining us for AZTechCast. We'll see you next time.